Hello, this is section 2.8. We're going to graph some linear inequalities in two variables. So our central question for today's lesson is, what does a dashed boundary line on the graph of an inequality represent? So our objective is we're going to be able to graph linear inequalities in two variables. All right, so key concept. What is a linear inequality in two variables? So as you saw from the previous sections a little while ago, we can have a linear inequality in one variable, okay? In one variable, and that might have been x was less than or equal to 3. And as we saw, we would graph it, find the number 3 on the number line, close circle, and shade to the left. Well, today we're going to take a look at two variables. So we have x's and y's, and here are all forms that we could have. Less than or equal to, greater than or greater than or equal to. So we want to be able to graph this. The first thing we're going to do is talk about when is an ordered pair a solution of a linear inequality. Well, that happens when I substitute in x and y, I get a true statement. Okay? So for example, we're going to tell whether the given ordered pair is a solution to this inequality. So for a, we have 0 and -3. So remember, that is x and y. So all we do is substitute in the point. We're going to put 0 in for x, and we're going to put -3 in for y. And what we do is we evaluate, and we get 6. Is that less than or equal to 6? That's true. Therefore, this ordered pair is a solution. Okay, now let's try the point by 5. Again, we're going to substitute that in. So 5 times 5 minus 2 times 5. Is that less than or equal to 6? So 25 minus 10, is that less than or equal to 6? Is 15 less than or equal to 6? Well, that's a false statement. So this is not a solution. Okay, now for C, we're going to do, again, substitute in. So 5 times 1 minus 2 times -2. Is that less than or equal to 6? Is 5 plus 4 less than or equal to 6? Is 9 less than or equal to 6? That's false. So this is not a solution. And then lastly here, we have 3 times 3, or 3 comma 3. So 5 times 3 minus 2 times 3. Is that less than or equal to 6? What is 15 minus 6? Is that less than or equal to 6? So that is 9. Is 9 less than or equal to 6? No, that's false. So we have not a solution. All right. So for guided practices, go ahead and on your Ed puzzle for 1, 2, 3, and 4, determine if this is a solution to the inequality. All right, welcome back. Let's go ahead and quickly check this. So we have 5 times 0 minus 2 times -4. Is that less than or equal to 6? So is 8 less than or equal to 6? This is false. So not a solution. Let's check 2, 2. So 5 times 2 minus 2 times 2. Is that less than or equal to 6? So 10 minus 4, we get 6. Is that less than or equal to 6? True. So this is a solution. Okay. -3, 8. So 5 times -3 minus 2 times 8. Is that less than or equal to 6? So -15 minus 16 is -31. Is that less than or equal to 6? That is true. So this is a solution. All right, and then -1, 7. So we have 5 times -1. Oops. 5 times -1 minus 2 times 7. Is that less than or equal to 6? So 5 minus 14, I think that's going to be 9. Is that less than or equal to 6? No, that's false. So this is not a solution. Okay. So our next concept is we're going to graph a linear inequality in two variables. So the graph is the set of all points that are a solution. Okay, so what we're going to do is basically two things. We're going to first graph a line as normal. Okay, as we're graphing a line, we have two conditions. We're going to have a solid line if we have less than or equal to or greater than or equal to, because that means it includes the points on that line. If it's a dashed line, we're going to have strictly less than or strictly greater than, because it does not include the points on that line. And then step 3, we're going to shade above or below. And this will be a picture of what we get. You see we have a dashed line, so no points on that line. And we have points underneath. So everything here, if I picked a point here, that would give me a solution. If I picked here, that would give me a solution. If I picked a point here, this would be not a solution. Okay. So let's try example 2. We're going to graph the line x is less than or equal to 5 in the coordinate plane. So if you recall, this is a vertical line. So we're going to find 5. And then I know I want to do a vertical line, but I have to think, is this going to be solid or dashed? Well, it's less than or equal to, so I know I'm going to draw a solid line. All right. Now for shading, we pick a point. So the easy point to pick is 0, 0, and we can always pick that point as long as it doesn't lie on this line. So we're going to substitute in 0. Is that less than or equal to 5? Well, that is a true statement. So therefore, we are going to shade everything on this side. And you can make this as pretty as you want. Now, if we got a false statement, if we picked a point over here, we would have a false statement. Okay? Therefore, we don't shade, and we would shade on the opposite side. All right, let's try example 3. So we have 3x minus 4y is greater than 12. So we could do two ways. We could do graph this the intercept method. Or we could graph this with the y equals mx plus b method. So most of you like y equals mx plus b, so let's go ahead and do that method. So 3x minus 4y is greater than 12. I'm going to subtract 3x from both sides. So you have negative 4y is greater than negative 3x plus 12. And I'm going to divide everything by negative 4. So we have y is less than 3/4 x minus 3. Notice I had to flip the inequality because I divided by a negative number. All right, now we'll go ahead and graph it. So we have negative 3 on my y-intercept, up 3 units, 1, 2, 3 over 4. Up 3 units, 1, 2, 3 over 4. And then before I connect the dots, I look at my inequality, strictly greater than. So that means I'm going to dash this line. And then now I need to test a point. So let's again press 0, 0. And I'm going to substitute that into my original equation so I don't make a mistake. So is 0 greater than 12? That is a false statement. So I'm going to shade below the line. Okay, so I'm going to shade on the opposite side of where I picked my point. Okay. All right, so for guided practices 5 through 10, go ahead and try each one of those. And then I will show you the answers in Edpuzzle when you do that. Okay. Now, for example 4, and in the guided practices 11, 12, and 13, we really can't do this yet. So you're going to hold off on this, and this is going to be after we do section 2.7. Okay, so next week we will come back to example 4 and then these guided practices. So what you're going to do after the Edpuzzle is you're going to do your homework except for problems 22, 24, and 26. We will do this next week after we cover 2.7. Okay? And hopefully you are productive.